What about your physics video talking about sound and light and things of that nature?
Yeah, well, we won't talk about that because nobody likes that subject. It's funny how few views those videos get, like 50 views. The videos got like, what, 60 views? I mean, nobody likes the subject of physics.
It's a shame because I remember I talked to you about it a couple weeks ago and you were talking about special relativity and you always being the same distance from light, even no matter how fast you go, you're always distant from it and everything. It's interesting.
Yeah, well, I don't think they get it, you know. I just think people are misunderstanding relativity because, they always do these thought experiments, and these thought experiments are, well, what if you were traveling, three-quarters the speed of light? You can't travel one-quarter the speed of light. Physically, you start falling apart. So it's just wrong for people to talk about thought experiments that they're not getting why there's a time dilation. There's a time dilation because your matter is no longer fucking matter. You're turning into energy. You start going anywhere near the speed of light, you are no longer material.
Did you say something? I'm trying to remember if I understand you right. You said something a few weeks ago about there being like was it in each photon almost has like a little clock in it or something, or each neutron or something like that.
Yeah, well, I
Your
suppose
slit experiment.
obviously there's an element to it when it comes to like radioactive material. There's a reason why it decays at a certain period of time, and so yeah, the time is built into its creation, and so it's all created in different stars. So when you have a hunk of uranium, every one of those uranium atoms came from a different star. Okay, they didn't come from the
Yes.
same place. They weren't born in the same place. They were born at very different times in space, and so they have a very different history. So yeah, they're on a different clock, and that's why they decay in a different time.
If you think you took one from one star and one from another and you put them together, what do you think would happen? Would they affect each other's time or would they still go along in that way?
Well, I just think that time has to do with how you can almost look at it as orbits decaying, so there's a time when the orbit decays, so it's like the space station fell out of space eventually because its orbit decayed. So it's the same kind of thing except on billions of years of time scales, so it's a whole different kind of time scale. So yeah, those effects they're not going to mesh with each other too much. But there is
Do you think
the jitter in matter. Atoms are moving in the sense that their electron is always moving into different orbits, and its balance, its center of gravity is constantly changing. And so
yeah.
that's a frequency built into the atoms itself. So every atom, depending on its atomic weight, is vibrating at a different frequency. And that's what makes this subject interesting when it gets to quantum mechanics and why does light, how it goes through glass and why it does what it does in glass. And I think that
Yeah.
can all be explained based on the fact that there's different elements inside each element, each compound inside the glass, the atoms inside of it as as connected elements are vibrating at one frequency and the atoms themselves are vibrating at individual frequencies, and those frequencies are essentially opening and closing the door, so to speak, to the
Yeah.
structure of the glass. So it's almost like one of those time vortexes, but it's like the doors are going in and out, in and out, in and out, and that's what's changing how much light gets through.
So do you think the effect is just an amalgamation of these different doors opening, to use your terminology?
Yeah, well, I think that's what the quantum effects are based on. So I don't think there's anything magical in the photon. I think there's something magical in the matter that it interacts with, right? So they never take into account the matter the photon is interacting with. They keep talking about what the photon is doing, and there's no point in talking about it. It's doing something so simple, right? It's moving at the speed of light in one direction. It's doing one motherfucking thing, and it's what the matter is doing is the important thing. And how
So
is
you
the
think they're
photon
looking in the wrong
interacting?
place?
Yeah, I just think they're obviously. I think they are. Yeah, I think the complexity is in the structure of the material, not in the structure of the photon.
I know, do you, what do you think about not, like, the whole idea of the observer effect and the minute you measure quanta, it affects it, basically, and you can't measure it and have it be in its natural state at the same time.
Well, I think it's just a truism, okay, that there's nothing, let's say, there's nothing smaller than photons, right? Especially, like, say, the highest frequency photons would be the smallest ones, which would be like cosmic rays or whatever. So
Yeah,
there's nothing smaller you can bounce off of it. So obviously, the only way you can interact with it, it's like having a Volkswagen going down the road 30 miles an hour, and I want to find out how fast it's going. I have to throw a Volkswagen at it, right?
yeah,
That's going to tell me how fast it was going, but it's going to make a fucking mess, right? There ain't going to be
yeah.
no Volkswagen left, okay? After I hit it with my Volkswagen, it ain't going to be a Volkswagen anymore.
So do you think there's ever any way around that we could ever intervene at that level without affecting anything? Do you think that's an inviolable law?
No way to interact. So I'm just saying we don't have any structure that we could possibly interact with it. So there's nothing small. Again, I'll just say the same thing over again. There's nothing smaller. So there's no
Yeah,
way to throw something smaller. I can't throw a tennis ball at it. I can't throw
yeah,
something smaller. So I'm stuck. You're stuck. There's no way to get around that paradox. There's no
yeah,
way to make it visible. You can only understand it theoretically. You can't understand it practically. There's no experiment you could conduct to know for certain. All you can know for certain is the theoretical part. You can understand the principles and the laws. So I'm saying, yes, we can make it predictable. Once we understand the mechanism, we won't have to base it on probability anymore. We'll say for a certainty what a certain photon is going to do. But we're never going to be able to do it. We're never going to be able to do the experiment because you're never going to be able to test it.
yeah. Just some things you can't break down.
Yeah, no, you'll only be able to deduce it once you have enough evidence of how all the other parts are working, and you'll find these final pieces of the puzzle you'll pop in, but it's like having a black puzzle piece. You know what I mean? There'd be no way to
Yeah,
tell where it goes
like
until
a
you have
black
the other.
hole, even.
Well, I'm just saying, there's no way to detect until you have the other pieces in place, right? You can't put it in place beforehand. You have to wait till the other pieces are there.
Yeah, like I was saying with the black hole, they can't actually see it, but they can look around it and see the planets moving and be able to tell their speeds and tell there's something there.
Right, and like I said, we'll be able to figure out that there are variables within photons and within matter that are creating the quantum effects. And so it's not a probabilistic thing, it's an absolute thing. We just don't have those variables yet. We just don't understand all those gates and all those mechanisms. But as soon as we understand
Yeah.
those gates and mechanisms, we'll know exactly what's going to happen.
I mean, like,
One
I'm
thing
wondering
I've
if physicists actually believe that there's like a true randomness in all of this, because, I was looking up how to make random number generators and programming and all that, and some people think that if you hook up a computer to a Geiger counter, which is hooked up to a piece of uranium that's decaying, it can be truly random or some bullshit like that.
Well, it could be random beyond any need for anything. Like random by definition is just an irregularity that's beyond your tolerances. You know what I mean? So it depends
Yeah,
on
but
what
they're
your
saying like it's truly random,
well, I know. Well, I'm just saying
which,
in a sense, it is truly random in the sense that it's as random as a 15 billion year old universe could produce. And so, based on the fact that it's got a billion years, let's say, of irregularity built into it, it's going to be a pretty funky dance. Okay, it's going to be as random as you want random to be, in the sense that you won't be able to tell because it's so densely random. It's so densely irregular. So it has so many variables caught up in it. It is so irregular that there's no way you could not perceive it as random. So you could never see its unrandomness because you'd never build anything that has so many like say with computers, a random generator on a computer, you can find the flaw in the randomness by just forcing it to produce millions of pixels at a time, right? So if you use a random number generator and then produce video with it, you can see patterns develop, and you'll start to see lines and different things show up because you'll defeat the random number generator. Okay, it'll lose its randomness, and you'll see patterns. All right, because you're demanding more from the math than the math can produce in terms of irregularity, and so you're seeing the irregularities and the regularities that are built into the mathematical structure. But I'm just saying there's nothing we could technically build that could be more that could display the non-randomness of radioactive decay, because there's an apple is to the Earth what a atom, what a say that the right way, right? What an atom is to an apple. Okay, so you have to realize just how many, atoms there are in just a tiny amount of uranium, and so there's no, there's just it's so dense in terms of its random capacity that you could never display. Well, anyway, I've said it as best I can say it.
Yeah, I mean, I get all of that, but I'm just wondering, because I don't really keep up with the physicists or whatever, like, do they actually believe, like, there is some sort of, like, magic in there? Like, or are they just sort of,
well, yeah, there's
like, throwing up their arms and saying, I give up, I'm just going to pretend it's probability, I'm not going to try to figure it out or whatever?
I don't know why they do it exactly, because it seems really stupid to draw that conclusion, because obviously even in the quantum, the stuff that you're talking about is like whether the photon is in, say, in this circle, and you're saying it's random where it is in this circle. Okay, it could be in 1,000 locations in this circle. And it just seems silly, when you have such a small amount of randomness to conclude it's random. You know what I mean? That to me is a silly conclusion when you could say, oh no, that's just the part we're not seeing. I mean, there's definitely, we could make that circle smaller and smaller and smaller with a little more information, and eventually make that circle 0. So I just think it's silly for them to conclude at this point that it's truly random and not realize that it really probably just has to do with the fact that photons have a history, and their history makes them unique. Each photon is in a different electromechanical state, and their electromagnetical state is going to determine their behavior. So it's just silly to say they're all identical, because we know they're not identical. They didn't travel the same distance. I mean, that's the big flaw in the two-slit experiment, is that they create an experiment that is deliberately trying to create eccentric photons. See, so they have a really long distance between the gun and the target, and they put a thing in between it, because what they're basically trying to do is get photons to bounce off the surface, bounce off the back wall, and then go through the slit. So they're trying to get photons that have traveled eccentric lengths of time distance to go through the slit. So that's the variable they're creating. So instead of having a consistent stream of photons that go straight through the slit, the whole point of the experiment is to filter out the eccentric ones. That's why they create the initial opening that forces the photons through the initial opening, because that's basically a random photon generator. They're basically creating eccentric photons to do the experiment with. So there you go, right there. They're screening for non-similarity, and so they're automatically trying to create photons that are a different age and have traveled different, that have a different life history. And so as soon as you do that, of course, the photons will behave differently because they have a different origin.
Yeah,
So
and
is
if
this
you just
kind of
moved the gun closer, it would be less eccentric.
Well, exactly. I mean, if you just had a gun that shoots straight, right? I mean, this is the whole point, right? They say don't use a gun that shoots straight, because then, yeah, the effects won't happen. So the whole idea is to create bullets that are coming in all kinds of strange directions and have all kinds of weird and eccentric spins on them.
So how do they get away with it? Because it's so contaminated.
Well, I don't know why they get away. Frankly, I don't understand. The damn thing's 100 fucking years old, right? The two-slit experiment's been around 100 fucking years. Einstein, shat on it, but he didn't shit on it hard enough, and so he left enough of it that it could peek through the shit, and it escaped. But I mean, it should have been blown up as bullshit a long fucking time ago, and I can't believe some asshole like me has to show up to sit there and do this. Why should it be my job? I mean, fuck. But yeah, this is bullshit. I mean, this quantum crap is that. It is fucking crap.
Well, I guess you have to do it with a lot of other things, so the physics isn't any different, right?